Good morning. I am Shailendra Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today I am going to discuss power amplifiers, what are power amplifiers and how they are categorized. As you can see, there are several applications where we need amplifiers. And power amplifiers are the devices which can provide significant output, through which the device can operate, like audio amplifier, and as well as there are several other applications of power amplifier that we will discuss soon. So, first of all, let us see what are amplifiers. Any device which can amplify the signal will come under the amplifiers. Let us consider this is an input signal and you can see it very clearly that its amplitude is this much. So, if you want to increase its output, for example, if you want to get this much output, as you can see its amplitude has been increased. So, it will come under amplifier. Mathematically, you can say that any device whose output is equal to, as you can see here, input multiplied by some constant A, and where A should be greater than 1. And you can, this is one particular example where input and output both are out of phase by 180 degree. As you can see, it happens in common emitter configuration, as you all know this. So, power amplifier is something that can be amplified voltage, current. So, the term power amplifier, although technically incorrect, because generally we will not amplify the power. So, you should not concentrate on power, you should concentrate on voltage or current. So, it is to understand to mean an amplifier that is intended to derive a load such as a speaker, a motor, etc. So, in other words, you can say that power amplifier is a device which converts low power signal to high power one. Actually, depending on the operation, for example, if this is the input signal from 0 to 360 degree, for small signal amplifiers, we have seen that will get output for throughout 0 to 360 degree. But in case of power amplifier, we may get output from 0 to 360 degree, we can get output from 0 to 180 degree, even less than 180 degree. So, depending on this, these amplifiers or power amplifiers are classified, such as class A power amplifier, class B power amplifier, class AB power amplifier and class C power amplifier and class D amplifier. Our class D amplifiers are for the digital signals. So, you can see in case of class A power amplifier, the output signal varies for a full 360 degree cycle. That means you will get output for 0 to 360 degree. So, input and output both will be of similar type. That means a distortion will be minimum. However, class A power amplifier provides minimum efficiency of 25%. Now, see, in this way you will get output in case of class A power amplifier. If I will talk about class B power amplifier, then in case of class B power amplifier, you will get output from 0 to 180 degree only. So, due to this, class B power amplifiers have more distortion in comparison to class A, but they will provide more efficiency. As you can see here. You will get out from 0 to 180 degree only. You will not get any output from 180 degree to 360 degree. And you may get surprised that what you will get for 180 degree to 360 degree. Then for that you can use two class B power amplifiers. One will provide you output from 0 to 180 degree, another will provide you output from 180 to 360 degree. So you will get good efficiency as well as output for the full cycle. Now, actually there is one problem when we will discuss class B power amplifier. That time you will come to know that class B power amplifier have one demerit, that is of crossover distortion. That means class B power amplifier provides crossover distortion, and we never want any kind of distortion in amplifiers. So to avoid distortion, we will use class AB power amplifier, and in case of class AB power amplifier, the conduction will be between 180 degree and 360 degree. That means, if we will see this, that means in case of class AB power amplifier, conduction will be from 0 to 180 degree and even more than 180 degree. You can see this is, for example, this is 180 degree angle and this is 360 degree angle. So conduction will be more than 180 degree. You can see this. So by using class AB power amplifier, crossover distortion will automatically eliminate. And you can see they will conduct between 180 degree and 360 degree. Now class C power amplifiers. Class C power amplifier is biased in such a way so that it will conduct less than 180 degree. Their biggest advantage is high efficiency. Generally, they are used in tuned circuits such as radio communications. Class D power amplifiers is a form of amplifier operation using pulses, that means digital signals, which are on for a short interval and off for a longer interval. So you can see class AB power amplifier can conduct between 180 degree to 360 degree, and they will provide maximum efficiency between 25% and 78%. Class B power amplifier, now you know. In case of class C power amplifier, they will conduct for less than 180 degree and they will provide efficiency more than 78.5%. Class D power amplifier, they are used for the pulse operation. Typically, they will provide efficiency more than 90%. Now let us discuss series fed class A power amplifier. If you will look into this diagram, it will look very similar to that of a simple BJT circuit, and it is also that circuit, but here we are using power transistor. This is the difference between normal, that means a small signal amplifier, and power amplifier. In case of power amplifier, we will use power transistor. And in this way, you can calculate base current, collector current, and collector emitter voltage. These are the conventional techniques which we have used several times. Actually, we will discuss that how the amplifier can be biased in such a way so that it can conduct for 0 to 360 degree, 0 to 180 degree, and even less than 180 degree. So if I will talk about the Q point and biasing, then you know this is the DC load line. So I must discuss AC operation of the transistor try to concentrate over here. This is the actually these are the characteristics of the BJT. This is VC output voltage and this is the output current. This is the DC load line. And we have considered that we have chosen the Q point in the middle of load line. Then what will happen? If you will apply any input signal, you will get output for the full cycle, that means from 0 to 360 degree. Even if you will increase the variation of input signal, that means amplitude of input signal, you will get the full cycle output. And if you will keep on increasing the input voltage, then there is a possibility that the signal will be clipped off, but signal will be clipped off from both the sides, from positive cycle as well as from negative cycle. So we will know in prior that what can be the variation of input signal so that signal will not get clipped. There is another possibility that you will shift the Q point towards X axis. In this case, what will happen? If you will increase the amplitude, then there are the chances. If you will increase the amplitude, then there are the chances that only this portion will be clipped. This portion will not be clipped. This portion will be clipped, as you can see here. If you will shift point closer to the saturation region, then in this way we will get the output, and there are the chances that this part will get clipped. So if you want that transistor should operate, or if you want to design class A power amplifier, then you should choose Q point in the middle of load line. And if you want that transistor should be work as a class B power amplifier, then in that case you should choose Q point at the X axis, that we will discuss later on. And the output voltage upon output power upon input power is the efficiency of the device. So in this case, input power and output power can be easily calculated, and output power is the VCC square upon 8 RC, and input power is VCC square upon 2 RC. So if we will put into this relation of maximum output power upon maximum input power, then we will get that it is 25%. So series fed class A power amplifier will provide you maximum efficiency of 25%. If you will take transformer coupled class A power amplifier, then they can provide you maximum efficiency of 50%, but cost of circuit will increase, and that circuit will occupy more area because transformer will be included in that circuit. Now class B power amplifier. In case of class B operation, it is provided when the DC bias leaves the transistor biased just off. The transistor turning on when the AC signal is applied. Okay, that means there will be no biasing. So whenever signal will be applied, the device will be in conduction mode and you will get the output. And you can see this is the input signal, this is the output signal. Okay, and you are giving input for whole cycle, that means from 0 to 180 degree, but you are getting output from 0 to 180 degree only. So to get output for whole cycle, what we can do, we can use two circuits. One half circuit that will provide positive half cycle, that means from 0 to 180 degree, and another circuit, another half circuit that will conduct from 180 to 360 degree, and at the load it can be combined, so you will get the output like this, that means from 0 to 360 degree. And this operation is called as push-pull operation. Okay, why it is called as push-pull operation? Since one part of the circuit pushes the signal high during one half cycle and other part pulls the signal low during other half cycle. You can see, you can use this circuit also. In this case, this device will conduct, this is NPN transistor, this is PNP transistor, this will conduct for the positive half cycle, this device will conduct for negative half cycle, and at the output, you will get output from 0 to 360 degree. There may be another circuit where you can use the center tapped transformer, and then you can use the phase reversal technique also. That means this signal will be in phase. If you use this, the signal will be out of phase, and then you can provide this input to two transistors. Okay. So there are several techniques which can be used for the push-pull circuit. This is technique which we have discussed in very brief. That means I told you that you can use center tapped transformer. Now in this case, this output is provided to one transistor, this output is provided to another transistor. Okay. So one transistor will conduct for one half, another transistor will conduct for another half. That means you will get output here for the whole 360 degree, and then it will be coupled to this, that means secondary winding of this transformer, and then by using this you can drive any load. Okay. This is complementary symmetry circuit, that means one transistor will be NPN transistor, another transistor will be PNP transistor. So one for the positive half cycle, this transistor will conduct and you will get output like this. Obviously it will be the amplified output. For the negative half cycle, PNP transistor will conduct and Q1, that means NPN transistor, will be in off condition, and you will get output for the negative half cycle, and obviously it will be the amplified output. So this is how you can get the output for full cycle. Okay. Earlier I told you that there is one problem that is arised in case of class B power amplifier, and that problem is of crossover distortion. So in case of crossover distortion, what will happen for the positive half cycle, where transistor 1 was conducting, whenever the voltage across base emitter junction will be less than 0.7, this VB voltage, transistor will be in off condition, and whenever transistor Q2 is conducting, whenever the voltage VB will be less than 0.7, that time Q2 will enter into the off condition. So for this time you will not get any output. So you can see your input was not like this, your input was this, and you are getting output like this. If I will redraw this, you are getting output like this. So this is nothing but this is the distortion, or this is crossover distortion. If I will plot both input and output in the SAM graph, then you can see this is the input signal, and this is the output signal. So, this is the problem which is arised in case of class B power amplifier, and this problem can be eliminated, minimized with the help of class AB power amplifier. Actually, in case of class AB power amplifier, what we will do? We will bias the transistor in such a way so that transistor will conduct for more than 180 degree. That means, if I will explain you, then if I will bias it for more than 180 degree, that means it will conduct in this region also, maybe up to this point. It will conduct more than this. It will conduct more than this. That means obviously this problem will be eliminated. This is what class AB power amplifier can do. However, the efficiency of class AB power amplifier will be less than class B power amplifier. So, the advantage of class AB power amplifier is it will minimize or eliminate the crossover distortion, but its efficiency will decrease in comparison to class B power amplifier. So, this is what which we have to discuss in this lecture. In next lecture, we will discuss class C power amplifier and class D power amplifier. Thank you.